Welcome to Spring LIB.
31.84. We have an RLC circuit with a resonant frequency of 6 kilohertz. It's being driven at 8 kilohertz, and when that happens, we're told that the magnitude of its impedance is 1 kiloohm, and its phase constant is 45 degrees. And so then we want to find the values of the three components. So for part A, when the phase constant is 45 degrees, this means that the resistance has to be equal to the net reactance. And so then the impedance just becomes R times the square root of 2, because you have a thing plus itself under a square root sign, which gives you the 2, and it's all would be multiplied by an R squared, and so the R comes out. So then R is Z over the square root of 2, which is 707 ohms. Now to find the the inductance, first of all, it's helpful to note that the angular frequency of the driving is 2 pi times 8,000 radians per second, so 16,000 pi. So then we know that XL minus XC is equal to R. And so then this is the difference between the capacitive and inductive reactances, and that this equals 707 ohms. 7 ohms. And we're also told that the resonant frequency is 6 kilohertz. So that'll be 12,000 pi radians per second. And so we can, in order to substitute for C, since we don't know it yet, we can replace it with 1 over omega naught squared L, because we know that omega naught is 1 over the square root of L times C. So we can put this into here and then solve, then we just solve it for the inductance. And so we find that that's 32.2 millihenries. Now that we know the inductance, we can, instead of using this relation to get rid of the capacitance in this other expression, we can use it to find the capacitance, and that works out to be 21.9 nanofarads.